Now let's look at a new assembly line. Once again, let's start by creating a variable a and putting the number 5 into it. We have come across a loop, specifically a while loop. We use a loop when we want to repeat the same section of code a number of times. With loops, like with an if statement, conditions are used to control the program flow. Typically, a loop will repeat while a particular condition is satisfied. We can see a scanner at the start of the loop here, before the code we will be looped through. And if we don't meet its requirements, we will move past the loop onto the next part of the conveyor belt. This scanner's condition is while a is less than 7. This condition is true, and so we are allowed to pass the scanner into the loop code, which increments a, so now a equals 6. Once we reach the end of the loop, we are brought back to the scanner to check the requirements. The condition is still true, so we pass through once again, and a becomes 7 before we are brought back to the scanner. Since the condition no longer holds, we are moved out of the loop onto the next section of conveyor belt. We come to another loop, but this one has a scanner at the end of the code instead of before it. This is a do-while loop. We use a do-while loop when we want to check our requirements at the end of a loop instead of at the start. The location of the scanner can change the number of times we go through a loop. The requirement for this loop is the same as the while loop. Even though we do not meet the requirements, we still pass through the loop once, since we have not yet been scanned, and a is increased once more, becoming 8. When we reach the end, we are scanned and it is determined that we do not meet the requirements. In a do-while loop, we always pass through the loop at least once, even if we do not meet the requirements. If a loop contains code that we want to run, but we don't know if the condition will be met, we use a do-while loop to ensure that the code will always run at least once. This loop has a scanner at the start, a variable creation machine, and a machine that will increase or decrease the newly created variable by 1 each time it passes through it. This is a for loop. A for loop is a special kind of loop that creates its own temporary variable, most often a counter that controls the loop execution. In a for loop, the condition generally checks the value of the counter variable, which is either increased or decreased by a set amount every time it reaches the end of a loop. This is all declared in the opening statement. We use a for loop when we want to have a greater control over the number of iterations we go through. Keep in mind, we can refer to the variable the for loop creates while we're within the for loop. For example, we can add or subtract the temporary variable from other variables we have. Now let's get back to our conveyor belt. We've reached a for loop that looks like this in code. When we enter the loop, the variable I is created and is given the same value as a, which is 8 at this point. And every time we reach the end of a loop, I is reduced by 1. And when we go back to the start of a loop, the scanner checks the condition of I being greater than 0. Once we get into the loop itself, we execute the statement that adds the value of I to the value of a. A becomes 44 by the time we exit the loop. We have come to the end of this conveyor belt, and therefore the end of our code.